Welcome to Prince Maths Clinic, the e-learning solution at your pace and time. Good morning, good afternoon, or good evening from wherever you are joining this class. Here we are going to be treating this exponential equation. It's called an exponential equation because the powers are variables. Whenever you have powers to be variables, we say they are what? Exponential equation. So, looking at the first question, we have that 4 to the power of x minus 4 to the power of y is equals to 960. Now, what do we do? For 4 to the power of x minus 4 to the power of y, they both have the same base, right? But look at the power x and y equal to 460. So it means that x must be greater than y. So let's assume x is greater than y. So if x is greater than y, it means that x will actually be y plus another value, which is also a constant or an integer. Let's call that constant k. Therefore, it means that anywhere I have x, I can put in this value because x is greater than y. This is what it implies. So therefore, I have that my 4 to the power of x will now become y plus k because x is equals to y plus k. Then minus 4 to the power of y, all equal to 960. Right? Going from the laws of indices, if you have a to the power of b plus c, it means that it is actually a to the power of b multiplied by a to the power of c. So because of the same base, their powers were added. So we are going to use the same law to what? To multiply this. So treating this, it means that we actually have 4 to the power of y multiplied by 4 to the power of k minus 4 to the power of y, all equals to. Now I want to break this 960. 960 is the product of 64 times 15. And 64 is 4 times 4 times 4, which is 4 raised to power 3 multiplied by 15. Good. So 4 to the power of 3 again is 64 times 15 gives us 960. So I can factor out 4 to the power of y because I have 4 to the power of y here and 4 to the power of y here. So I have 4 to the power of y. Now what I have left here is simply what? 4 to the power of k. Then since 4 to the power of y is out, so I have just 1 left here. All equal to 4 to the power of 3 times 15. The interesting thing is that when you have a number 4, this is an even number carrying a power. This is an even number 4 again carrying a power. This number is always even. It's always even. Try with any number 4 to the power of 1, 4 to the power of 2, 4 to the power of 3, 4 to the power of 4, 4 to the power of any number will always be even. And look at it here, 4 raised to power 3 is also what? Even. So we are going to what? Equate at this point that 4 to the power of y is equals to 4 to the power of 3. Now we know from the laws of indices that when the bases are the same, therefore the powers are equal. So therefore we can say that our y is equal to 3. Remember what we have already established that our y is equal to 3. mean by this value here is even. The one in the bracket is odd. Looking at what we have in the bracket is odd. What we don't have in the bracket is even. So we have equated the even number to the even number. This is odd. This is odd. Also, we can say that 4 to the power of k minus 1 is equals to 15. Then if I move this here, I will have 4 to the power of k equal to 15 plus 1. And 15 plus 1 is 16. So what does this imply? It means that 4 to the power of k. If I want to put 16 to have a base of 4, it means that I will say 4 to the power of 2. So the bases are the same again. Hence, k is equal to 2. But recall, our x is greater than y. And we said that x is equal to y plus k. So therefore, I want to get the value for my what? My y. Hence, x will now be, what is y? Y is what? 3. And what is k? K is what? 2. And what is 3 plus 2? 5. So it means that my s is 5. Therefore, my x is 5 and my y is 3. So that is the answer that satisfies x and y in this equation. Let us try to see if our result is correct. 4 to the power of x. We have found that our x is 5. Then we have found out our y is what? 3. You can see that x is obviously greater than y. So, and 4 to the power of 5 means 4 times 4 times 4 times 4 times 4. 5 places will give you 1024. Then 4 to the power of 3 will give you 64. If you subtract, you are going to get 960. Looking at the second question, we have that 5 to the power of x plus 5 to the power of x plus 5 to the power of x is equals to e to the power of 5. So, write out the question. Then, there are two ways to resolve this from the beginning. You either factor out 5 to the power of x, then this 5 to the power of x divided by 5 to the power of x gives you 1, 1, and 1, then equal to e to the power of 5. Or you count 1, 2, 3 and just say 3 times 5 to the power of x. They are all the same because if I add 1, 2, and 3, I'll still get 3 multiplied by 5 to the power of x. So I'm going to say this is what? 5 to the power of x multiplied by 3 equals to e to the power of 5. Now, when you have a case where you have something like this in exponential equation, you either take the log of both sides or you take the ln of both sides. And since I have e here, I'm going to use ln. And ln simply means log to base e. Good. So therefore, I'm going to do this. So this becomes ln 5 to the power of x multiplied by 3 equals to ln e to the power of 5. Now, in logarithm, if I have a log that is in base e and I have a times b, this log simply means what? Log a to base e plus log b to base e. That's what it means. Therefore, it then means that I can split this that is being multiplied here in this form. This becomes ln 5 to the power of x plus ln 3 equals to ln e to the power of 5. Also, from this law of logarithm, that if I have log b carrying the power of a, the power comes to multiply the log and it becomes a log b. Therefore, this power will multiply this power will also multiply this. Becomes x ln 5 plus ln 3 equals to 5 ln e. Now we know that our ln e is log e to base e. Remember, ln means log in base e. So I will know that when a log and a base are the same, it cancels to become 1. Therefore, and you can also press your calculator for ln e, you are still going to get 1. So this becomes x ln 5 plus ln 3 equal to 5 times 1 gives us 5. So what do I do here? I'll move this to this part. So this becomes x ln 5 is equals to 5 minus ln 3. So this becomes my x, therefore ln 5 is equals to what? 5 minus ln 3. So I want to divide both sides by ln 5 and here by ln 5 as well. So ln 5 will cancel ln 5. So I have my x to be what? 5 minus ln 3 over ln 5. This is 5. Now ln 3 will give us 1.0986 and ln 5 will give us 1.6094. Then if I subtract this from this, I'm going to get 3.9014 all divided by 1.6094. And when you divide what you have here, you are going to get 2.4241. So that is the value for x, which can be verified by putting the x value for x here, and see what it's going to give us. E to the power of x is 148.4. Then let us see 5. We got the value to be 2.4241 plus another 5 to the power of 2.4241 plus another 5 to the power of 2.4241. 5 to the power of 2.4241 will give us 49.4736 plus add all of this is going to give you another approximate value of 148.4. That proves that our result is correct. This is Prince Maths Clinic. Kindly subscribe to this channel, and if the video was helpful, kindly share it with your friends. Bye for now.